Great. Let's look at example 2 of characteristics of polynomial functions. Example 2 says, each table represents a polynomial function. Use finite differences to determine 1. The degree of the polynomial function, 2. The sign of the leading coefficient, and 3. The value of the leading coefficient. Okay, so before we continue on with this, we should discuss something called factorial and factorial notation. So let's look at this for a second. Factorial notation. What this is, it means the following. Okay, n is a whole number, and we write n factorial is equal to n times n minus 1 times n minus 2 times all the way times 3 times 2 times 1. So better said with an example. For example, if we have something like 3 factorial, what this means, that 3 factorial means that this is equal to 3 times 2 times 1, which is equal to 3 times 2 times 1 gives us 6. Therefore 3 factorial is equal to 6. Let's say 4 factorial. 4 factorial will be equal to 4 times 3 times 2 times 1, and this would be equal to 4 times 3 gives us 12 times 2 24 times 1 gives us 24. So this is equal to 24, and so on and so forth. And eventually you can generalize that n factorial is equal to that. It will always be that would always be the case for the n factorial. And of course 1 factorial is equal to 1, and 0 factorial will be equal to 1. So 0 factorial is also equal to 1. Okay, let's continue on with our next with the example. Okay, so we have this table of values, and let's look at a first. Okay, we need to find the degree of the polynomial function. So we start looking at the constant differences, at the finite differences, in fact. So if you recall, when we're looking at linear relations, the first differences will be constant, right? And when we look at quadratic relations, the second differences will be constant, and this, and so on and so forth for higher degree polynomials. So let's see what in order to find the degree of this polynomial function, let's find out where the finite differences are located. So let's start finding out the first differences. Okay, so minus 12 minus 36, that becomes plus 36. This becomes 24. Minus 2 minus 12, this becomes 10, and so on. Okay, so it appears that the third differences are constant. So these are our finite constant differences. So what this means, that for question, the first question, right, our equation here has a degree of 3. So let's collect that now. A degree of 3. Okay. Now what is the sign of the leading coefficient? Since the third differences are constant and are positive, then we know that the sign of the leading coefficient is positive. So let's put here positive. Okay, so plus. And now what is the value of the leading coefficient? So as we said before, factorial notation. So what this means is the following. Let me move this up a little more. So what this means is the following. That means that our leading coefficient, if you guys recall from many polynomial functions, right, I'm just going to put an example here, or at least, it's going to be ax cubed plus bx squared plus cx plus d, and so on and so forth, depending on how high the leading coefficient is. So in this case, we're saying the leading coefficient, what is the value of the leading coefficient? So for that, what we need to do is the following. The leading coefficient will be equal to the finite differences is 6, so let's write down 6 over here. It's equal to the leading coefficient times n factorial. Now n is going to be the degree of the function, so in this case is 3 factorial. So 6 equals, what's a times 3 factorial? This becomes 6a, because 3 factorial is equal to 6. So 6a. And now let's solve for a, which is our leading coefficient. 6 divided by 6, that gives us 1. So the leading coefficient, well, this is the sign of the leading coefficient, and the leading coefficient is going to be equal to 1. So that's the value of the leading coefficient, and it is positive. Let me write down here sign of. Okay, so that's how we got the leading coefficient. We can start looking at example B. At example B, right, we have a similar table, a little bit larger, and we would do the same thing, the same calculations. I'll leave this up to you to answer the rest of the questions, and or you can pause the video and see if your answer will match mine. Alright, so the answer is a degree of 4, sign of leading coefficient is negative, and our leading coefficient, the value is -1.